Chandrayaan-2 is an Indian mission to send an orbiter, lander, and rover to the moon. The three vehicles launched as one combined spacecraft in July 2019 to lunar orbit, and the lander, carrying the rover, attempted but failed to touch down in the moon's southern hemisphere. The orbiter continues to study the moon from above. The big news is coming out from ISRO about new discovery on lunar surface that changes everything and help us know more about how Earth and Moon are formed. Isn't it an interesting thing to explore? Let's dig deep into this more and watch out the detailed analysis of this discovery by Chandrayaan-2 in this video. The Chandrayaan-2 orbiter hopes to build on the data collected during the Chandrayaan-1 mission using improved instruments. Science goals include mapping the moon's topography, investigating surface mineralogy and elemental abundances, studying the lunar exosphere, and looking for signatures of hydroxyl and water ice. The X-ray spectrometer class on the Chandrayaan-2 orbiter has mapped the abundance of sodium on the moon for the first time. The serene radiance that fills the vast expanse of a night sky is the reflection of sunlight from the moon's surface, a major part of which is from the bright lunar highlands. The rock and soil samples that the Apollo 11 astronauts brought to Earth showed that these regions, which are remnants of an ancient lunar crust, are mainly composed of silicate minerals in the group plagioclase feldspar series. While these are common minerals found on Earth, lunar samples have a variety of the mineral that contain more of the element calcium than sodium, which is an alternative, following the general trend in compositional differences between Earth and Moon. A loss of volatile elements including alkalis like sodium and potassium on the Moon could be traced back to the time when Earth and Moon formed together in a solar system that was young and fiery and very interesting to know as well. Findings from Chandrayaan-2 suggest there are two kinds of sodium atoms on the Moon's surface, those that are loosely bound on the surface and those that are part of the minerals. External agents such as solar radiation liberate the loosely bound atoms more easily, thus acting as a source of the atoms in the lunar exosphere. These sodium atoms can be nudged out of the surface by solar wind or ultraviolet radiation more easily than if they were part of the lunar minerals. Also shown is a diurnal variation of the surface sodium that would explain the continuous supply of atoms to the exosphere, sustaining it. An interesting aspect that widens the interest in this alkali element is its presence in the wispy atmosphere of the Moon, a region so thin that the atoms there rarely meet. This region, termed an exosphere, begins at the surface of the Moon and extends several thousand kilometers, merging into the interplanetary space. Porter and Morgan in 1988 measured from ground sodium atoms in the lunar exosphere. Since then, ground telescopes have taken images of this faint sodium glow around the Moon, which is just the color of light emitted by a sodium vapor lamp. What has been elusive is the source of these atoms on the Moon's surface. The new findings from Chandrayaan-2 provide an avenue to study surface-exosphere interaction on the Moon, which would aid development of similar models for Mercury and other airless bodies in our solar system and beyond. At the end, answer this question in comment box. Where is the headquarters of ISRO? Thanks for watching till the end. If you like space videos, make sure to subscribe to Space IQ and press the bell icon to get notified when we upload new video about space discoveries and much more.